Alright, hey y'all, it's Miss Summers with your notes today on air masses, fronts, and weather. So we want to know how are air masses classified and how do fronts create weather and why did I put air masses and fronts together? Alright, so we'll look at masses first, then fronts, and then you have a couple of assignments that have you reviewing the layers of the atmosphere along with air masses, and then an assignment with air masses and fronts. Alright, both are pretty short. They shouldn't take you too dreadfully long. Alright, so let's start with a couple pictures. Alright, you might have seen pictures like this. This one's from last year in October. It's a map of the United States, and you can see the different temperature variations throughout. And what I wanted you to note is, you have this really big area of blue where temperatures are really cold, and then it kind of just abruptly stops. And on the other side of it, it's very warm. Alright? And here we have a similar picture. Again, these colors represent different temperatures. You have really warm ones right here, and then really cold ones, and they're separated by this line. All right, and that's what we're looking at today. Why do these lines exist? Why is there such an abrupt change from cold air to warm air? Where does that come from? Okay, so let's start by talking about air masses and what an air mass is. An air mass is just a big old blob of air that has similar characteristics throughout. All right, so this air mass is going to be a little bit different than this air mass, but it's all going to be the same throughout. All right, when we look at an air mass, we want to know its moisture content. Is it wet or is it dry? And its temperature. Is it cold or is it hot? Because that's going to change what kind of weather it brings. Okay, obviously a wet air mass is going to bring precipitation more likely. A cold air mass is going to bring cold weather, that type of stuff. All right, so here's a map of air masses that I like to start everyone off with. It has our four main types and then a bonus type up here. Don't pay so much attention to this particular one because we're not going to talk about them. But look at these four masses here, and hopefully you see a little pattern. Look at the ones that have M over it. All the M ones are occurring over water. All the C ones, even this guy up here, are occurring over land. Interesting. And then there's also, hopefully you see a pattern between the second letters as well, P and T. I wonder what those stand for. Well, let's looky. These letters are not randomly assigned. These letters are given to air masses based on where they're formed. Okay, so when I say or ask for a classification of an air mass, I'm looking for these letters. All right, these are how we classify them based on where they are formed and their characteristics that match. Each air mass has two letters. One letter will stand for its moisture. Is it wet or is it dry? And the other letter will stand for its temperature. Is it cold or is it warm? So let's start with the first letter. The first letter shows moisture content. It will either be C or M. There's a couple other there. I think there's also there's another letter for E, but that doesn't occur in the United States, so we're not going to worry about it. All right, C stands for continental. Continental means it is dry because it formed over land, okay? So here we have a C forming over here, over Canada. Here we have a C forming over here, over like northern Mexico, the American Southwest. Here we have a C forming over like the North Pole, Greenland, that type of area. All right, so C is dry. M stands for maritime. And if you know what M-A-R means, it means ocean or sea. Like in Spanish, the word for ocean is de mar. That branch of the armed forces that used to go with the Navy are the Marines, because they used to be part of the Navy. A submarine goes underwater, all that good stuff. All right, maritime forms over oceans. and they have a high moisture content. It's wet, all right? So C is for dry, M is for wet. The second letter stands for temperature. Temperature, all right? And so we have T and P. That's funny. All right, T stands for tropical because it forms in tropical areas. These green ones are T as well as this orange one. These are just warm areas, okay? If I were to visit, the Dominican Republic, I expect it to be warm. If I go here and visit, northern Mexico, it's usually warm. All right? Warm air is going to form here. P stands for polar. Think about a polar bear. Polar bears live where it's cold. All right? So MP, this is over water, but it's also cold. CP, it's over land. It's going to be dry, but it's also going to be cold. All right? This A, because I know someone's going to ask me about it, A stands for Arctic. That just means super cold. That's all that means. All right? But I just want you to know these two. All right? So you end up with those two sets of letters, C and M and P and T, with 4 possible air masses. And these are the main 4 that affect the United States. So let's figure out their characteristics and source region for each of these. All right, let's do this one first. CP. C is continental, which means over land, and P is polar, which is cold. So CP, write this down, CP air masses are dry and cold. They're going to form over places that are far, far north, over land, like Canada. Canada's a fine place for a continental polar air mass to form. All right, MP, M, remember, is maritime, so water forms over an ocean, but P is still polar, it's still cold. So MPs are wet and cold. They will form over northern oceans, like the North Atlantic, the North Pacific. They will bring cold, wet weather. All right. Our next one, CT. Remember this C, just like it did here. This C stands for continent, dry. T is tropical. CT air masses are dry and warm. They will form over deserts, like the Southwest, Mexico, places like that. MT, M, just like it did here, stands for maritime, which is wet. T stands for tropical, just like it did here. So these will be wet and warm air masses. They will form over warm oceans, like the Gulf of Mexico. Let's see, around the Caribbean Sea. All right, anywhere that's sort of tropically and has lots of water. There's your maritime tropical air masses. All right, these are the 4 classifications I expect you to know. All right, now, how do those air masses go back to these pictures that we saw at the very beginning? It has to do with the fact that air masses, because they have different temperatures and different moisture contents, they have different densities. And things with different densities don't mix together. Very good. All right? Instead, they make a boundary called a front. So these maps, even though they don't have this symbol, you can see where fronts are. So here's a front right along here in this map, right around like Tennessee, Mississippi, Alabama, those places. And then here's a front right around here on the Midwest. All right. Fronts are important because this is where a lot of the weather stuff takes place. Like if it's raining or storming or something like that, chances are it's at a front. All right. We're going to talk about 3 fronts today. Technically there's 4. I'm not going to ask you about the 4th one. It's called occluded. Look it up on your own time. Okay? So, a cold front occurs when cold air is pushing in and replacing warm air. All right? Cold, dense air forces warm air to rise rapidly. Remember, warm is less dense than cold, and things that are more dense want to be at the bottom, and things that are less dense want to rise up. All right? Because the warm air is rising, remember in the troposphere, this is from yesterday's notes, in the troposphere it gets colder as you go up. So the warm air gets cold, it condenses, it makes a cloud, and then the cloud makes the weather. The cloud makes precipitation or severe weather. This symbol for a cold front is this blue line right here with the triangles. The triangles show which way the cold air is moving. So here the cold air is right here, and it's moving this way towards where the arrows are pointing. Here's a nice little diagram showing you how a cold front basically works. All right, it's this wall of cold air moving in. The warm air, as it meets it, it gets whoop, pushed up. Rising air makes severe weather. All right, so this was like last year. We had this little news article. Let's see if we can't see it. It happened to occur literally right as I was making this PowerPoint. I was like, oh, that's interesting. Yeah, October 2019. It was a cold front that had moved through Dallas and had spawned quite a few very strong tornadoes. And this cold front, this wall of cold air, was pushing its way towards North Carolina. So the concern was when it hit the warm air, it was going to rise up very quickly and create that severe weather here, which fortunately it was not as severe as it was for our friends in Texas. Right? Our next front are the warm fronts. Warm fronts move in. All right, the warm air is still going to rise, but instead of rising up really, really fast, it's sliding over the cold air. Like in this picture, it kind of slips and slides upwards. It doesn't go whoop, it doesn't go straight up. All right, because it's still rising, it's still going to make clouds. All right, rising air creates clouds. Write that down somewhere. Rising air creates clouds. So you'll have clouds and rain ahead of the front, because the front's right here. This is ahead of the front. But behind it, you'll have warm temperatures and generally clear weather. All right, so the symbol for a warm front is this red line with these little semicircles. I like to think of them like warm little sunrises. And again, the little warm circles, the circles point which way the warm air is moving. All right, so the warm air is over here. It's pushing this way, replacing this cold air. All right, and lastly, our last front is the stationary front. This symbol for a stationary front is like if you took a warm front symbol and a cold air symbol and smashed them together. It just looks like that. So you had the cold air trying to move one way and the warm air trying to move the other way, and they stall out. They stop moving, all right? Hence why it's called stationary, all right? Because you have warm air meeting cold air, the warm air still rises, just like it would at any other front, and you're going to end up with several days of snow or rain. And that's a problem because those kinds of conditions can lead to flooding. So it's always important to know what kinds of fronts are around you, you know. Cold fronts will bring you severe weather. Warm fronts will bring you a little bit of rain, but kind of nice weather afterwards. Stationary fronts give you lots of rain for a long time. All right, so that's why we're interested in these. All right, so we have our three fronts. You have your three symbols. The big thing, okay, that I want you to take away from this, aside from those four types of air masses, is to know what kinds of weather come with these fronts. All right, so if we look at these pictures, hopefully you can tell me something about, is it a cold front, is it a warm front? Whoops. In this particular picture, you can see a line. This is a radar, and you probably know that these darker colors, red and orange, that's really severe. Anytime you see a line like this is generally a cold front, all right? The cold air is pushing this way towards the east. Here's where the warm air is rising up and creating this line of thunderstorms. So this is a cold front. In this picture, we have, this is a Canadian forecast, actually. This is over Canada. Which way is the warm front advancing? Well, I would go to the warm front. Here it is. It's pushing towards the east. And what's kind of nice about this little diagram is this particular map has cloud coverage. I can see here's the clouds ahead of the warm front because the warm air is rising slowly over the cold air it's replacing. Towards the back, I can see a cold front behind here, and I can see there's some rain down here near like Western Canada. That's like near Washington State. All right, cold air is bringing in. All right, so this place just warmed up because a warm front just passed, and it's gonna get cold again once this cold front passes. All right, so you have a couple of assignments to look at today. Take a look at both of those. They shouldn't take you super duper long. Let me know if you have any questions, and I'll get back to you, okay?